get a lot of options to learn for. So you can look in for that. So to understand today's concept, which is on deep learning, it is important to know the definition or the understanding of what AI is, what is machine learning, what are the types of machine learning that you have learned last week, which is supervised, unsupervised, and reinforcement learning. What are the algorithms that you have, they can apply? That is very important. These are the basic things that you need to no. So the difference between deep learning and machine learning, one is in machine learning, you will explicitly tell the machine what to learn and how do we use this intelligent system of approach. Similarly, deep learning deals with neural networks, which my colleague is going to talk about today. So both are aspects of AI itself. So it is important to know the basic concepts or foundation of AI and as well as the aspects of AI to get deeper into deep learning concepts. So I think we have 130 participants so far. I request all the participants to please join within time. We'll just wait for another 5 minutes and then we will start with today's session. I hope most of you have completed your course on AI and NLP, natural language processing, and obtained your certificate too. If I can get a confirmation from participants, we'll be happy about it. Yeah, thank you. Yes, yes, you're right, Mansi Shah. You're right. In machine learning, we'll have a structured data, wherein we'll have the data, and based on the data patterns, we'll be able to get the attributes of the data or the features of the data. Whereas in case of deep learning, it is more deals with more complex problems and unstructured data. We have also noted down the questions that was put on the chat box. By the end of the session, we will try to reflect on the questions that has been asked as well, based on knowing all the aspects of AI. And in case we are not able to answer your questions, not to worry, I have made a note of it. And we'll refer to our seniors here who are more experts in that field, and we'll get back to you with the answers. Aisha, I request you to please send in your error message to Hershakti team so that they can forward it to us, or you can put it to support team as well. There is no issue in getting the certificates. If you have gone through the course completely, all the subtopics have been taken. Just see the learning progress and wait for 24 hours to 48 hours. You will be getting the certificate. Thanks, Girija ma'am, for joining in. I have made you the co-host as well. I hope you can unmute yourself now.
Yeah, Prithvi.
Yeah, sorry for that.
Thank you for that. No worries. I hope we can get started, right? I'll just
yes, we have day by day, each week we see less number of participants. So please don't lose interest just because the concepts are new. You'll get a hang of it once you are thorough with the basics. And please join in before 11, please.
Hope my screen is visible.
Yes, ma'am. Yeah.
Yeah, thank you. Very good morning to all the participants. My name is Girija. I'll be the facilitator for today's session, Introduction to Deep Learning. So hope my screen is visible to all of you. Yeah, thanks for the response. I hope we shall get started. Good morning once again. Thanks for joining. So would request, as and when you complete certain sessions, we'll be sharing the course link as well along with this. So request everybody to go through the entire course once again and take up the self-assessment at the end of each course. And as said, certifications generally takes 24 to 78 hours to get generated. In case, sometimes it will get generated very soon, sometimes it will take some time. It depends on the platform or whatever is going to happen at the back end, right? So in case if you haven't got the certifications, request all of you to wait for at least minimum 48 hours. And then in case still if you're unable to get the certifications, please drop a mail to the Springboard support or you can contact the Hershakti team, right? So with respect to the today's agenda, the very first thing is you're going to start why and what is deep learning. And what is the difference between the deep learning and the classical machine learning? Moving on to the next, you'll be learning about artificial neural network, wherein you're going to learn overview of neural network and the components. What are the components that are present as part of the neural network? And then the deep learning. You're going to learn the process forward as well as the backward propagation, activation functions, which is very plays a very important role when you're going to choose the task, what you're supposed to do, and what function or what algorithm to choose to perform a certain task. And you learn about optimizers later. Deep learning for image analytics, which is convolutional neural network, the classification, introduction, architecture, as well as the applications of it. And then deep learning for sequential data as well, which is the recurrent neural network. Deep learning is used for two main tasks. So both the things will be covering which includes the introduction, challenges, as well as the variants of the RNN. Later at the end, we are going to summarize what are the things that has been learned during the today's session. Hope you are all on the same page. Okay. Yeah. Now, the very first agenda of today's discussion is why and what is deep learning. Before moving on to the deep learning, we'll just brush up some of the concepts which has been learned in the earlier sessions. That is artificial intelligence. Very simple questions. Let us understand what is intelligence first. Intelligence is nothing but what? Ability to learn, understand, and think in a logical way about the things. We as a human beings exhibit this particular ability. Hence, we are going to consider as intelligent people, right? So, for example, you'll be able to play a game of chess and you'll be able to avoid certain things and you'll be able to express your way of thoughts and you'll be going to involve in the conversation. Many more things, we'll be able to classify the things, right? So, all this task requires the intelligence. So what do you mean by artificial intelligence? These intelligence as a humans we get by birth, right? So when you talk about artificial intelligence is nothing but it is a science of making machines do the things that would require intelligence if it will going to do it by men. This is the definition which was given by Marvin Minsky. If the machines can able to perform certain activities like picking up the things and if it is able to classify the objects and taking the data based on the decisions and it will be able to answer the questions, right? These are some of the applications where we are introducing artificial intelligence to the machines. Many more applications like you might have heard about the self-driving car, chatbots, IVRs, right? Face recognition. All these things are examples for artificial intelligence. When you come talk about artificial intelligence, there are two types of intelligence again. One is descriptive, another one is a generative AI. So I'm just giving a brief introduction about AI and then we'll move on to the deep learning. Okay. Descriptive and generative. What do you mean by descriptive? Descriptive in the sense, human beings by natural, they'll be able to differentiate or distinguish between win and loss, faulty and non-faulty, living and non-living, etc. Yes, it's a narrow classification. They have natural intelligence. So inspired by the human being, many of the artificial intelligence algorithms have been developed. It will going to mimic the human intelligence. If the systems can also perform tasks like classification, clustering, grouping, or regression, this capability we call it as a descriptive AI, right? This is a descriptive AI. Is it binary? Yes. In addition to descriptive, humans also possess generative intelligence, which means they have the ability to create the art or creating a music, composing a music, writing a poem. Okay, these are all creativity. This will not be there for all of them. Each one of them has different creativity by themselves. If machine can exhibit the creativity or having a generating capabilities, we call it as a generative AI. Right? So this is nothing but a state of the art AI algorithms which can also create. It can create text, it can create image, it can create art, and many more. We term this as a generative AI. I hope you got the differentiation between a descriptive and generative. Descriptive is nothing but a narrow, whereas a generative is which will having a capability to generate itself. So based on the requirement, for example, an image is shown and we expect the machines to caption that particular image. This is the creativity, right? So that generative or the creativity AI is a little bit different compared to a descriptive or what we call it as a narrow AI, right? This is about the AI. In AI, you might have heard about different aspects of AI. You talked about NLP, deep learning, computer vision, robotic process automation. There are many more. These are the different aspects of AI. AI is very big ocean. In that, each of this machine learning, NLP, computer vision, RPA, and all different aspects of AI, right? So in that, machine learning is one of the major aspect of AI. Okay, so machine learning is again a bigger picture. In that, deep learning is a part of it. Got it? So when we are going to use a machine learning for to perform various tasks, we have found some of the error rate. For example, if we are identifying the image, we don't see that much accuracy while using the machine learning algorithms. That's the main reason why we have moved to the in-depth concepts, which we call it as a deep learning. When you talk about machine learning, there are two different types: supervised learning and unsupervised learning. In case of supervised learning, deep learning is a part of the supervised, right? So we prefer deep learning to perform various tasks. What are the different types of tasks we will be able to perform? And how deep learning has become a very popular one nowadays. You might have heard about, see, AI is not a new concept, it's a decade-old concept, but still now AI is in boom. The reason is because we have computational devices. We have the devices where it is going to compute you data in terms of GBs and terabytes, and we have huge large amounts of data to process. So these are the main reasons why we come up with the machine learning, and then we are moved on to the deep learning, wherein the accuracy of the output is much more. Okay, so deep learning is a architecture, is a new architecture, so which were developed to build the models. Especially when you're going to solve certain complex problems, we prefer to go with the deep learning. And deep learning concepts, why it has become more popular is we wanted to mimic the human intelligence. For example, the brain. See, the human exhibits the intelligence from the brain functionality, right? So deep learning, we have used the main similar functionality of the brain. We call it as a artificial neural network. I'm not on mute. request others to please confirm. Are you able to hear?
Yes, ma'am.
Okay, I think one of them has replied saying that it was on mute. Please check the network connections at your end, right? So, in case of artificial neural network, or how is the model has been classified? It is input, output, and the hidden layer. We have been classified into three different layers. The entire architecture or the entire model, what we call it as a model, has been divided into three layers: input layer, hidden layer, as well as output layer. So input is the one which we receive the data, output is the one which we are going to send it as a output, right? So hidden layer is the one where it will function. Yes, Vidya, I am going to continue with the slides, but we are understanding why we are coming into the deep learning. Then definitely post that, we're going to just, I'll change the slides. Okay. So what are the main functionalities we are going to use with the concepts of the deep learning architecture? Image analytics, or computer vision needs, or for analyzing the sequential data, for example, stock prices or the speech, for processing time-based data, for NLP, for encoding data, for creating a large language modules. We call it as a LLM, which we have this concept in generative AI, right? These are some of the reasons why we have come up with this deep learning. Okay. Now you have understood what is artificial intelligence, why we have chosen deep learning, right? So in this slides, I have given you the causes or the reasons why we have chosen the deep learning. Since we have large amount of data, automated feature extraction, we have improved accuracy, end-to-end learning, and handling non-linear relationship as well. So, however, we always prefer to go with the machine learning because deep learning, because it become very costlier. It will not be able to afford for all the simple problems. Depends upon the problems, or depending upon the issue or what task, we are going to choose whether we can go ahead with the deep learning or the traditional machine learning. Deep learning is generative AI, so we cannot classify in that way. So when you talk about AI differentiation is generative AI as well as a descriptive AI. The differentiation is different. Deep learning, it is an aspect, it is an architecture, right? So AI for cloud, artificial intelligence is included in cloud, yes, because you know that we are going to have huge amount of data, right? So if you have the cloud basics, it depends upon the what I want to say is depending upon the task. For example, if you are in the administration side or you are in the infrastructure management, definitely you need to have understand the cloud concepts, right? So in case of this, we are learning only the concepts wise here. We are not seeing the applications where we are using this AI, right? So we'll differentiate. Let us see the difference between the deep learning as well as the traditional machine learning in the coming slide. So machine learning are designed to make the predictions, right, based on the limited number of inputs. Whereas in case of deep learning, we require a vast amount of data. And machine learning, it works on the lower end machines, whereas deep learning, it requires a very powerful machine, preferably with GPU. We work on smaller data set and here huge data set. Feature extraction is handled manually by the domain experts. Feature extraction is nothing but we need to dig out what are the features that are there. For example, if you would like to differentiate between two different objects, we have to identify the characters. For example, whether it is round in shape, what's the color of it, what are the characteristics of each of the object, in order to learn the classifications of a new object, right? So those feature extractions is done manually by the machine learning, whereas in case of deep learning architecture, it will be taken care automatically. And when it is done automatically, definitely you can expect zero human errors. Whereas when you do manually, there are chances, it depends upon expertise of the person, there are chances that we may miss out some of the features to identify as well. So that it will going to affect the accuracy of the results. And the performance is very low. In case of machine learning is normal, minimal. Sure, I'll go a little slow. Whereas in case of deep learning, we see a very good improvement in the performance. So what are the things that has been explained? You can see here in the pictorial representation: input, feature extraction, classification, and the output. Whereas in case of deep learning, this part, the one which the cursor have put, feature extraction as well as the classifications, will be done automatically. Got it? So that is the main reason why we prefer to choose a deep learning. But again, it doesn't mean that machine learning is a failure. It is always the best, but the thing is, it depends upon the complexity of the problem, complexity of the issues that what we would like to solve. Based on that, we have to decide whether we can go ahead with the machine learning or we can go ahead with the deep learning architecture. Okay, this shows the difference between the machine learning and the deep learning. I was talking about deep learning, right? What is deep learning then? It's nothing but a subset of artificial intelligence as well as a machine learning. It comes as a part of those two. And the term deep itself refers, right? The term deep itself refers to the number of hidden layers in the neural network. It will going to eliminate some of the data pre-processing that is typically involved in the, machine learning, as we were discussing, right? That's the main reason we use deep learning techniques to solve only the complex problems. Okay, so you can see we usually chosen this as a network architecture. This is the base that has been chosen for the deep learning. Now, what is the motivation for deep learning from the biological neuron? I said that it is taken as part of the human brain, right? The above picture represents the structure of the neuron. I think this is the biological concepts which has been studied in the schools. The structure of the neurons, you can see there are many more parts as well, but there are three main important parts: cell body, axon, and dendrite. These are the three parts what is that cell body? Cell body is nothing but, you can see in the middle portion, it's a core section of the neuron. Whereas dendrite, what is the main function of the dendrite? It collects the information from the previous neuron and passes on to the cell body. What is this axon? It's nothing but a long tail. You can see the structure here. It looks like a long tail, right? Tube-like structure. It carries the information from the cell body to the nerve endings, and from here it will get connected to the another dendrite. This is how our neurons are interconnected in our brain to transfer the information from one part to the another. So basically, the main functionality of this particular neuron is to transmit the signals to and from different parts of the body, right? So this is what the main principle or the funda that is being used in case of deep learning as well. Okay, now in the next picture, I'll show how artificial neurons was inspired by the biological neuron. Here, so neural networks, this concept you might have been heard, it's very long time, but it is in demand now. Biological neural networks and artificial neural networks are composed of the same components. For example, there was a cell body, dendrite as well as axon, right? Same thing here also. Axon transfers the output, so this is the output node. Dendrite receives the input. Whereas in the cell body, it's nothing but your hidden node layers, wherein the actual functionality takes place. Okay, in both of these cases, the building blocks are the same, and the functionality is to process and transmit the information. Here also, in case of hidden layer, it will process and transmit. There in the cell body, it will process the data and it will going to transfer the output. Okay, so both a biological inspired network of artificial neurons configured to perform the specific task. By seeing the structure itself, you can make out that you can find out the similarity between ANN and well as a biological neural network, right? So in the next slides, I'll show here, this figure shows the difference here. So here it is a neuron, right? Biological neuron, you see, this is nothing but your activation function, output, and x1, x2, x3 are the inputs. The below figure shows this is how the network is what? Collection of cells or the neurons, collection of group. It is nothing but a group, right? So this is what the network is. Similarly, in artificial neural network, this is one cell. You can see here, combination of cells, all interconnected. Similarly, in case of neurons also, all interconnected. 1, 2, 3. Here also, see, you can see 3 here. Okay, this is about the analogy between the biological neural network as well as the artificial neural network. Moving on to the next concepts. So now we have been studied what is the dendrite, axon, it's a cell body. Same way, what are the components of the neural network? We can see there are 4 main components of the neural network: layers, neurons, weights and bias, and the activation function. Let us not go in depth. I'll just brief you on what are these concepts. Artificial neurons, or we also call it as a nodes. These are nothing but the units in the neural network, or what we call elementary units in the neural network. It's nothing but a computational unit, one unit. Artificial neural network means group of units, group of computational units to perform certain tasks. What do you mean by layers? Right? These are group of neurons at different levels. Now ANN has one input layer, one output, and one hidden layer. Okay, nodes in the input layer are nothing but the nodes which we are going to feed it to the input feature values. Output layers gives the outputs, and then the layers between the input and the output are nothing but the hidden layers where actually performs the calculations. Right? This is the activation functions happens in the inner layer. You are going to select activation layer here. Okay, which activation function to use depending upon the task. When it comes to the weights and bias, weights and bias are the neural network parameters. Bias, I think you might have heard about this word many times. These are nothing but network parameters, wherein we'll be able to adjust this to produce a desired output. See, we know what is the input, what should be the output. Because as a human, you'll be able to come to a conclusion. This is what should be the input, this is the output. The processing should happen inside the hidden layer. While processing, if the output is not accurate, with the help of the weights and bias network parameters, you'll be able to adjust and you'll be able to get the desired output. Right? So in other words, weights, it will going to influence the input to get the desired output. Okay. So some of them are finding difficult to understand. I'll make it much easier now. Hope you are able to see these are the inputs, this is activation, these are the output. When you go through the course, I think it will very well explain. Now you just understand input, this is the output, and this is the hidden layer. So input can be any number. For example, simple example I'll give, prediction of a diabetic patient. What are the inputs? You're going to give the sugar level, the current sugar level. And what should be the output? We know that if it is more than 120 or 110, he's a diabetic. Less than that, non-diabetic. We know the output, diabetic or non-diabetic. Patient, what is the input that they are going to give? The age as well as the sugar level. So the process will going to happen inside this hidden layer. So for example, in order to get the desired output, we know what should be the output. If it is above 120, it should show it as a diabetic, right? If it is not coming, so we can adjust this weight and bias in such a way so that we'll get the desired output. Okay, so once you adjust and make the functionality works for this particular network, later whatever you're going to give the input, later next time when you can give 240, then it should process in such a way and get the desired results. I hope these concepts make easier for you in the coming slides. So how is the representation? How does it works? Okay, so here the representation of ANN, how it will be has been represented. So weights and bias, as it told that these are all the parameters, which means the values are adjusted to produce a desired output from the given inputs. Where we are going to adjust this? This is a hidden layer functionality which I'm showing, and this is the input and this is the output. These arrows. Okay, you're going to give the input. It will process and it should come to the output. So weight functions, weights and bias are after this processing the data. There are many mathematical techniques like stochastic gradient descent, ADA-grad, ADA-delt. There are so many algorithms or the techniques are used to search for optimal weights that will make the model accurate in its prediction. So it depends upon the task that whatever we are going to do it. Okay, activation function, we also call it as a transfer function. Right? So it's mainly used in order to help the network learn the complex patterns in the data. What are the different types of patterns that we're going to get as part of the data? Activation function, it's one of the major or integral role in case of the neural networks. What algorithms need to be chosen has to be decided by the data analyst. So we, as a person, are going to choose which algorithm is best suited for what type of problems. Without activation functions, the neural network is nothing. The working of the neural network will become like a linear. Okay. What are the commonly used functions? So forward propagation in the sense, see here, the main function is it will going to give input, the processing will take place and you're going to get the output. We're going to find out what is the error rate. Okay. So based on the error, if it is not that much accurate, so what happens? Again, we'll feed it back to the backward propagation. Again, we'll send the data. We'll modify the weights and bias values until we get the desired results. This is the forward and this is the backward propagation. There are many functions which will be used. Definitely in the coming slides, you'll be learning more about it. Okay. So forward in the sense that it will go from input, hidden, and then forward. Once the output is created, if it is not that accurate, we'll send the output back to the input. We'll again start doing the process, that's a backward propagation, until we get the desired result. Activation function, I said that we are going to choose the activation functions, right? So it's a mathematical functions which converts the input to an output. So there are so many functions, sigmoid, tanh, and then relu and the soft plus. So sigmoid also is called as a logistic activation function. Tanh is nothing but, you can see here it is a hyperbolic tangent function, hyperbolic. RelQ is nothing but rectified linear unit. RelQ is nothing but rectified linear unit. This is the one which is commonly used function, activation function. In almost all of the convolutional neural network or in the deep learning, we go ahead with this RelQ. And nowadays we have got the upgraded version of this function as well. We better go for this leaky RelQ is there, another extended or the next version of this RelQ. Usually prefer that. And soft plus or the soft max is also there. Usually all these three has certain limitations to use it. So we usually go ahead and prefer to use this RelQ functions. So here it definitely increase the computation type a little bit as well. And when we are going to find out, when you are going to get the desired results, there is something called as a vanishing gradient problem. which we're going to learn in detail in the coming slides. This gradient problem is more in other three functions, whereas here it will try to nullify it to the maximum extent. That's the main reason why we go with the rectified linear unit, or we also call it as a leaky unit, leaky ReLQ. Okay, so that we prefer to use. How does a machine learn with the neural architecture? Why DL, what is DL, and the components of the DL? These are the things now we have been learned. We have learned the architecture of neural network is made up of input, output, as well as a hidden layer. Neural or ANN is nothing but a subset of machine learning we designed to mimic the processing power of the human brain. We know how our human brain functions, right? We process the data in a seconds. So we have used the same architecture in case of machine learning or the deep learning as well to get the desired or the accurate output. Okay. Now I'm going to explain this with an example. I've already explained this with an example, but we'll go a little bit in depth. As I was taking black box example, which means this black box, we are idle. We don't know what's happening inside. So yes, the example is the same, diabetic prediction. Sugar level and age are the input, and diabetic or non-diabetic. Only two options we can get as an output, right? Either the person should be diabetic or non-diabetic. How the internal processing takes place, what are the internal functions or the which algorithms to use. We are going to learn how this processing takes place inside the black box. We are sure what is the input and we are sure what is the output. But what happens inside this is nothing but the processing unit that we are supposed to learn here, right? So this is nothing but what's happening inside the processing unit, or what is happening inside the black box. Sugar level and age, we already given it as an input here. For example, sugar level so and so, and age, for example, 60 plus years. Here again, you can differentiate. This is the input, this is the output, and this is nothing but your processing unit or nothing but your hidden layer. So activation function is carried out by the hidden layer, which is used to process the given input and provides the desired output. There are many activation functions, as I've shown in the previous slide, right? So that the data scientist, or what we call as a data practitioner, he is the ideal person to choose which activation function to choose based on the requirement, right? Here we have only two input, only one output. In case if you want to be accurate, we can have more number of input as well. We can put our weight, BMI, many more things. So what happens when we have more number of inputs? The complexity of the hidden layer should also be more. Definitely in that situation or in that case, you'll get a proper results or the accurate results. In this case, we have chosen only these two as the inputs, right? The output has only one option, diabetic or non-diabetic. In case, as I told, weights and bias are here. You can see here, weight 1. Bias is nothing but only one constant value. So the forward propagation is nothing but what? It forwards the forward path, which is a one-way direction. Weights and bias values can be adjusted. After the input, whatever we are going to give, we're going to adjust the weights and bias, and we're going to feed it to the hidden layer. So it will process. And again, weights and bias will be adjusted, and we are going to produce the output. Here, the output will be predicted whether it is diabetic or not. This is the normal function. What is this error estimation? The step 2. So, in order to get the accurate results, okay, it works with the expected and the predicted output. We know what is expected output and what is that predicted output. Whatever the output that we got, right, along with the expected output. So, in case if the error rate is more, then it will work towards a backward propagation to reduce the error rates. So we are designing a model in such a way that it should get the accurate results. More the error rate, definitely accuracy is less, right? Less the error rate, accuracy is more. So what happens in backward propagation? Again, we're going to modify the weight and bias. We'll feed it to the hidden layer. Again, we'll modify here and we'll going to get the estimated output. So we know what is this is the obtained output. We know what it is expected output. So we're going to check with that. What is the error rate again? Still not matching? Go back to the backward propagation. So we can improve the accuracy in case of machine learning, but we need to do explicitly. These things we'll do explicitly. Hence, we propose or use a DL technique which does this particular function automatically, and the accuracy of the output is also improved. Hence, deep learning is slow when it compared to the machine learning. Here, the network is a bit complex because we'll be having more processing input layers, more number of hidden layers, and more number of output layers. And this forward propagation, error estimation, and the backward propagation, this is going to do it automatically in case of deep learning. Hence, it is a bit slow compared to the machine learning, and the computational power required for this functioning also would be more. Whereas in case of machine learning, as a person, we do explicitly for this. And then we'll come to a conclusion. What is the function that we wanted to use in case of activation function? So these manual things will be taken care by the machine learning concepts. Few more examples definitely we're going to get a better clarity. It depends on the problems and the issues. We'll just move on to the next step. Fine, if you're going to give the input as a value, you know how to get the output. I'll just check, does it require coding? What are the weights and bias? Please matching. Okay, I'll definitely take up these questions at the end. So now, yes, bias is a constant value. Exactly. Used for adjusting the inputs. Is bias something computed based on the group of weights? Can you please? No, bias is not computed based on the weights. Bias is different. It's a constant. It is not having anything on the weights. Both are different parameters. Weights can keep adjusting, whereas bias we usually will keep it as a constant. Very rarely we'll change it. Does it require coding? No. Slope is weight and C is the bias. This will take little later in the next concepts. While discussing the algorithms, I'll show here linear regression. Yes, you are right. There are y is equal to wx plus c is a formula that we use to calculate. Bias is the error rate. Is the sophisticated gradient is nothing but a mathematical function which we use. Activation function doesn't convert the output to the desired output. Activation function usually performs the actual computation. Computation of the output is performed in the activation function. So in order to get the desired result, we use a technique called as by changing the bias and the weight values until we get the desired output. Activation function is the place where the actual functioning or the calculation takes place or the computation takes place. Soft plus and softmax is the same. Yes, is almost the same. Rel Q. Now, we don't use a programming for this. It doesn't mean that coding knowledge is a must here. Okay. So I hope that can I take chat GPT as example, since we are going on asking questions until we get the value. Chat GPT as an example, this is a different concept actually. The one which this is an application of this generative AI. Okay, this is the model for generative AI, to be more specific. What are the prerequisites to get into deep learning domain? Basics of artificial intelligence and basics of machine learning help you to get a learning of this deep learning domain. AI is a must because without knowing AI, you will not be able to proceed further. And then machine learning, if you know, then definitely you can differentiate what is deep learning, what is machine learning, and which one to choose to solve the particular task. In this course, explain the basics. So what basics you are expecting, Rashmi? So whatever the PPT that I'm using, everything is put it in the course. Please go through the course. I'll explain perceptron and epochs in the coming slides. Okay, I'll take this question at the later point of time. Okay, now Python, if you know it, is good. It's not mandate. Okay, now you have learned about how the deep learning concepts, what is architecture and all now, and why we choose deep learning comparatively to the machine learning, all these things, right? Now, we'll take few more examples. If an input is an image, how many neurons are required? Right? Neurons are nothing but a nodes, are nothing but a number of nodes, input nodes. What if the image size is so and so? See, these are the questions. If it is an image thing, how do we take? Deep learning for image analytics. We call it as a convolutional neural network. So, in order for the image analyzation, we go for a convolutional neural network, which is a type of deep learning. Deep learning is of three different types: convolutional neural network, recurrent neural network, and autoencoders. So let us not go in depth of all these things. We'll just learn what is CNN. CNN is nothing but a convolutional neural network, which is a type of the deep learning network specifically used for image analytics. Okay. So how do we learn this? How to understand? Assume you have a large number of images of the cats. Is there a way to train a machine to identify the cats with these images? Can the machine identify new cat that was not in the training data set? These were the questions, right? So in order to answer all these questions, first of all, we need to understand how do we identify the object? How do we know whether it is a cat or a dog or whatever might be the image of the? First, we need to analyze the image in order to identify what it is, right? So we do the identification of the objects by the features of it. Do you agree? So we identify the objects by its features. What are the features of the cat? So round in face, it has a blue eyes, it has 2 ears, whether it is straight or whether it is slant. So these are some of the features, right? So I'll definitely explain this in the next slide. Now, we identify the image with the features, by the object's features. Now, what do you mean by convolution? Convolution means rolling together. We roll the feature on the image one at a time and check the similarity with the known feature. That's what I said. We identify the image first. Feature on the image. For example, blue eyes. And we check the similarity, whether the one which we wanted to identify, it has a blue eyes or black eyes or has a brown eyes, or whether it's a straight line or curve, etc. And then we calculate the strength of each feature in the image. This is, see, we need to identify if more number of features resembles, then we can come to a conclusion. The new object or the new image is nothing but a cat or a dog. Simple example is tomato and cherries. Both are round in shape, both are red in color. So how do we differentiate between the tomato and the cherry? Will we identify certain unique features where it differentiate between these two? When the new image, when the new object comes with the red color one, so we'll be able to, we should be in a position to identify whether it is an tomato or a cherry, right? So how this particular image we analyze? I said that we are going to identify the image with the help of the features of each of the object. So how do we do that, right? So when there is an image picture there, how do we identify this? The concept of convolution is shown in the 3D pic here. So we roll the feature on the image one at a time. See, you can see here. Please observe this. and we check the similarity in this particular picture. Whether it's a straight line or curve, we calculate the strength of each feature in the image. This process is known as a convolution. The one which I'm showing you in the pictorial representation is nothing but your convolution. This is not a new concept. This has been used in image processing for a long time. When I was studying in my engineering also, we had a image processing subjects. This particular concept was used in that time. But convolutions in machine learning is entirely different from what we have been used for the image processing. But the concept is the same. The usage is different. Now, I'm just asking you to observe how the filter is rolled over the image. This we call it as a filter. The one which is been put it on this, which is rolling. This is nothing but we call it as a filter. Also call it as a feature. So what do we do? How the filter is rolled over the image? As mentioned earlier, we roll the feature of the image one at a time and we check the similarity with the known feature. If the portion of the image and filter are similar, this portion is similar to this, then the degree of overlap or the convolution will be maximum. This is how we are going to measure the similarity, or we'll try taking the records. This record of the feature which is having a similarity, we call it as a feature map. For example, this I'll show in a better, taking an example. I have taken a simple example of tomato and cherries. Now you can see cheetah and caracal. This is a caracal and this is the cheetah. Here, caracal has a pointy ears. See here, whereas it has a round ears. It is spotted, whereas we don't see here the spots. This has dark black lines here. So here we don't find much. So these differentiation data is called it as a feature. The abstraction of such features, okay, in the diagram, a feature is nothing but what? A small image, usually which is of size 2 into 2 or 3 into 3. It's a pixel dimension. You know, image means what happens? We're going to use the word pixel, right? So these features are called as a filters, kernels, or the weights in the deep learning. Whereas filters, kernels, or the weights are all the same. The process of learning features from an image is known as a feature extraction. See, we are able to extract the features. This is known as a feature extraction. Once we extract the features from an image, we use them. We use all these features to identify a new object or a different object. Right? So, similar concepts can be taken example of tomatoes and cherries. Similarly, other objects as well. So now let's define what do you mean by convolutional neural network. You understand how the convolution takes place. We're going to roll the filter over the image and then we'll start extracting the features. This is called as a feature extraction process. Now moving on to the convolutional neural network. It's a type of the deep learning algorithm particularly suited for image recognition or some of the processing tasks. You can see here, right side, there is a picture as well. So we are going to extract the features of this image. Clock, bucket, and the girl. We'll start extracting all these features. Okay. The process of feature extraction and object identification is carried out in case of convolutional neural network. We also call it as a ConNet. Okay. It consists of two main steps. What are those? We extract the features from the image and then we'll start classifying ears, round or sharply pointy ears, right? We'll start classifying the image. See here, in case of this image processing, there are set of filters that are used to perform a task. So these filters we already been ready. It's readily available. You need not start designing a new filter for a particular task. For example, if you would like to blur the image, the filter may look like this. And if you want to sharpen the image, the filter look like the filter or the what we call kernel or the weights is one and the same. I said that this will roll over the image. You will understand clearly in the coming slides. Other filters like Sobel filters can perform edge detection as well as other operations as well. Okay. The question is, how do we select a filter, right? Such as its overlap with the image is maximum or not. Convolutional neural network uses the learnable filters. We randomly select such filters and learn the required filters by training, just as in case of artificial neural network. Okay. These are certain set of filters. I'll show how this image will go into blur, how this filter will go into sharpen the image. See here, this is the image. We wanted to blur this image. This is the output. How do we did this? In the previous slide, you can see that, sorry, I'll show here. In the previous slide, you can see here, this filter is rolled over this image and we blurred this. Similarly, we have sharpened the image here. See here, this is blur, this is sharpen. And this is the edge detection. We already had the filter. So the key point is that these filters are predefined. They have fixed pixel values. Definitely, we do have a library of such filters. Okay. So vertical edge detection using convolution, how this image processing will take place. So you can see one of the example, this is a filter or the kernel. See here, this will reflect over here and this will calculate. This is the output. This is the input image. This is the kernel and this is the output. And the next, what happens again, this particular filter will roll overlap with this particular image and start calculating the output. Similarly, the third one. So I'll show here at the end what will be the output. See here what happens. This is what happened in every slides here. In order to get all, in order to fill this particular table matrix. So this will roll over the image, does the calculations, and you are getting the output. This is what the convolution process is. Okay. So now you can clearly observe what is a vertical edge detection using convolution. We have seen with an example. What do you observe from here? You can see the input of the image is more. This is the kernel and this is the output. You can see the difference between the input and the output. Input is bigger, whereas the output size of the image is smaller. Do you all agree? Right? Hope you are able to follow. I'm unable to see the questions here because if I start going through the questions in the chat box, the flow will get disturbed. That's the reason. Definitely, Prithvi, you take up those questions. If you could able to answer those questions, it will be good. Does it multiply the matrix? Yes. So I'll show once again. You see, you please observe how it has been calculated. So 0 into 0, 0 into 1. First one, 3 into 1, 0 into 0, 1 into minus 1. Similarly, 1 into 1, 5 into 0 is 0, 0 and 8 into minus 1 is minus 8. You can clearly observe. I'll show how it is calculated in the very first slide. See how it is 3 into 1, 1 into 1, 2 into 1, 0 into 0, 5 into 0, 7 into 0, 1 into minus 1, 8 into minus 1, 2 into minus 1. All this 3 into 1 is 3, 1 into 1, 4, plus 2 is 6, 6 minus 1 is 5, minus 8, minus 2. So totally we have come up with minus 5 as the answer. So same way, all the matrix is calculated. Later, we have come up with this particular output. Okay. So now everybody can observe the size of the input is bigger compared to the output. What we can come to the conclusion is definitely the output may not be that accurate. We'll be losing some input information. If it is the same, definitely we can predict, yes, it has a very good accuracy, but in this case, we may feel that output and input should be the same, but here in this case, it is small. So that's the main reason why this padding came into the picture. The convoluted image has different size than the original image. The convoluted is nothing but the output image. So there might be a shrinking in the output. There are chances that we may lose the information on the corners of the image, these corners. That's the main reason why we have come up with this padding. Why padding? Padding is nothing but there are chances that we may lose the information of the input. So padding is nothing but adding extra pixels outside the image. See here, this is the input. So what we have done is we have added extra pixels and we have added the value as 0. 0 means nothing, right? It doesn't going to harm anything. So what will be the output of this? There are different types of padding, valid as well as the same padding, or we also call it as a zero padding. Okay, padding is nothing but adding extra pixels outside the image. Okay, valid padding means no padding is added to the input feature. Yes, in this case, what happens? Output will be smaller than the input, but we are going to perform the convolution only on the valid pixels of the input. So out of this input, what happens? We'll consider only which is valid. Then only we are going to take it the output. Whereas in case of same padding, we'll add extra features, extra pixels, and then we'll perform the convolution. What happens? With the size of this casual padding, the output and input will be the same. This, you remove this. This, you are the one who has added extra things. Don't consider this. So input will be same as the output size. The most common padding which we use is a zero padding. We usually prefer to add 0 values because it does not going to harm any of the input features. Definitely with this, the performance of the model has improved. Okay, there is one more advantage I'll show here before we move on to the pooling. In this case, what happens, why we add 0 is, there are chances because all these corners, if you observe, it has taken only once. The kernel has rolled out only once. There are chances we may lose image at the corners of the input. Whereas if you add 0, so the corners, even though if you're going to do it only once, no issues because the value of that particular pixels or the matrix is 0, the last column. So input, all this will be overlapped twice or thrice in order to get the desired output. So when you do this, so this image, even the corners, if it has been taken only once, that's fine, no worries, because you're going to get the proper output. Okay. So you understood why we do padding. When there is a chance that we may lose the accuracy is not good, you can add the corners with 0 values and then try doing the convolution, and let's see whether we are going to get the accurate results or not. Right? So now coming to the pooling concepts. What do you mean by pooling? See, this is the low resolution picture. The convolution we have done many times, and these many channels are there. This is the high resolution output. The n filters will produce n into the number of input pixels. See here, n. How many are there? N filters. So there are so many layers. So for one, if you take so much, and if it multiplies, what happens? It will become lot of computation resources are required. If the number of pixels will become very large, it is very difficult to do the computation. So convolution produces a lots of data. So what do we do for that? So when there is a lot of data, then it requires more time to do a processing. So that's the reason we have introduced this pooling concept, where it is a convolution. It reduces the dimensionality of the feature maps. Okay. So how they work? There are two kinds of pooling. Either, see what happens. Very good example what I can give in the real time is, you'll be having many internal exams and one main exams. So there are many internal exams. Internal test we usually conduct in the regular academics, right? So we take the average of internals or only one of the internal marks where they have got the maximum good marks. So either you can go with the max pooling or average pooling. Because if we start considering all, then it will be a huge data for us to do a computation. So it requires a lot of manual power, computational time is more, and lot of resources are also required, right? So the complexity will become more. So in order to reduce the complexity of the network or the complexity of the task, we prefer to go ahead with the pooling. Just imagine when there is a lot of computational data is required, so go with the pooling, either go with the max or average, either of these. Okay, so what does this pooling meant here? This is the output, convolution output. We have seen that, right? So in order to reduce this, go with the max pooling. Either of these four, which is maximum, 6 is maximum. In these four, 7 is maximum. In this, 5 is maximum. In this, 6 is maximum. We have taken the max pool output. Whereas in case of average, you can go ahead and take the average of 4. Average of these 4 things. So this is the average pool output. Average of all the values in the respective field. I hope this concept is clear. Okay. So usually, max pool is a preferred choice instead of going for a average. Right? So now, how the pool layers? Now we got the only that whatever the output, this bigger output, 4 into 4 has changed to 2 into 2. Right? How we are going to fit to the fully connected layer? The main reason why we did the pooling is in order to reduce the dimension of the infit features. Now we can feed this data to the convolutional neural network. So this is the output. For example, if we give each element from the pool set is still a matrix. Earlier in the example, it was 2 into 2. Now it is 3 into 3. Let it be anything for that matter. A fully connected network cannot accept this matrix. It can accept only scalars, which means that it can be only in the one dimension. It cannot take 3 into 3. It can take only 9 into 1. It should be in this particular vector format. So what we are supposed to do is, the output obtained from the conversion process is still a multi-dimensional matrix data. But our neural network, whatever we have been designed, accepts only one-dimensional vector, or what we call as a scalars as an input. So hence, we go ahead with the flattening. Flattening is nothing but converting the matrix into a vector or a scalar, right? So nothing, we just take the same data, 1, 1, 1. So we have put it 4 to 1, 4 to 1 and 0 to 1. We have flattened the data. We also call it this one as a regularized method, regularization method. Okay. So this is the complete process. We have learned individual process, how this happens. So this is the complete process of the CNN. So this is the image input. In the very first slide, we saw in the convolutional neural, which we use for image analytics. Then convolutional output. We started rolling the kernel on this image and we got this many things, right? So after this, what we done, since this is huge, we did a max pooling. So the matrix reduced, right? And again, we did the padding, right? We did a padding. We want the same data. We don't want to lose the input. So we don't want to lose the information. We did the padding. What happened? The number was more. We took only the valid inputs here, valid data into consideration to do this padding. And then we did the pooling again, max pooling. So whatever the output that we got, we flattened it. And then we send it to the hidden layer for the further processing. So this fully connected neural network related to activation here. Activation means nothing but the processing. And then this is the desired output. So a CNN sequence is to classify the handwritten digits, right? So you can see 28 into 28 into 1 was the image. The output was 24. It was reduced. Then we did the pooling. It became 12. And then we did the padding. The main reason why we did padding is, instead of this 12 into 12, we have considered only the valid input, and then it became 8 into 8. Then we again did the max pooling, so we got 4 into 4. This has converted to a flattened data or the input, and we have provided to the convolution neural network. So this is the background things which will happen, which we are not going to notice. Now, what are the applications where we are using these concepts, right? So, medical image analysis, security, and the retail. See, medical image, the scanning reports where we are going to analyze the scanning. So this is a very big image. So the machine learning cannot be used here. So we prefer to go with the deep learning, where it will definitely, by just seeing the scanning report, it will be able to rectify what kind of a disease a human being is having, right? So medical analysis, automatically selecting features which are actually required to make the predictions, whereas in machine learning, we need to identify the features, right? So abnormality detection, or MRI scan, CT scan, X-rays and all. In case of security, especially used for surveillance to monitor the crowd, or the video footage for the crime, and facial recognition. For example, cyber departments use the facial recognition to find the criminals in a large group of people. In case of retail, what are the applications of this is labeling of the products on the image. Say, for example, when there is a demand, so we need to ensure that the products are in place during that particular time. So which one has completed, which one is running out of stock, we need to identify that. Definitely we can apply this convolution neural network applications here to identify this. Demand forecasting, the store can definitely become cashier free. You might have Amazon Go, right? You might have heard about the shopping app. So where people do the shopping, where there is no human intervention is required there, right? So we does the shopping. How do we maintain the stock, whether it is in demand or not? So with the help of these concepts, we can do that. Okay, this is the one form of the input. What are the other forms of data? So far we have seen relational data and image data. Relational data is nothing but the sugar level and the data. That is a core deep learning concepts. And CNN purely for image data analytics. What do we have the other forms of data here? We have one more type of the data, we call it as a sequential data. What do you mean by sequential data? Which is nothing but a different type of neural network called as a recurrent neural network. It is again a type of the deep learning. See, for example, why we go with this? See, when you have a fixed input, we know how to analyze the output. When we have an image, we know how to analyze the output, how to make the predictions. When the data keeps changing, for example, so you can see this particular example, stock thing. Previous day, this is the one, previous day share price and today's. How do we predict the future price? So unless and until we analyze the previous day stock price, index and share price, you'll not be able to predict this. So we have to analyze not only one data, we have to analyze a bunch of data here. So this we call it as a sequential data analysis. For this, we definitely has to have a different kind of architecture. That's the reason we go with the recurrent neural network. Okay. So can we solve the above problem by using NNN or CNN? No, not possible. That's the reason we go with the neural network. In this section, what we are going to, in this particular things, what we are going to discuss further is, why do we need different neural network to handle sequential data? And we definitely will also learn how to represent such networks. What are the salient features and the many more things. Recurrent neural network are nothing but a feed forward network. Here in this case, what happens? Data is allowed one way, but feedback is not allowed. This is not allowed. Whereas in case of recurrent network, so data is allowed to propagate forward as well as the backward. Feedback between the nodes and what we call the self-feedback, either between the nodes, it can be a feedback or it can be a self-feedback for the nodes is allowed here in this case. This is a one-way direction, the feed-forward network, whereas in case of recurrent network, it is a backward as well as a forward propagate takes place. That's the reason the name itself indicates recurrent network. So now how do we train this recurrent neural network? This can be trained using the gradient descent error optimization method. There are different methods. It is a little bit in depth. I don't want everybody to get confused with this. Just understand what is the concept behind it. How do we handle this and how that particular process takes place, right? Don't go much in depth because many of them it will be done automatically, but in a way you just need to understand how the concept runs at the back end. Here, these are all the input. This is how it goes. Whereas in case of recurrent neural network, so it will go reverse as well. The error is propagated back. Sorry, I have to go with the previous slide. So this can be trained using the gradient descent error optimization method. This is nothing but a method where you're going to reduce the error. Okay. Here in this case, what happens? The error is propagated back to all the previous time to optimize the parameters, that is weights. I told weights can be changed until we get the proper data. That's the main reason why we call it as a back propagation through time, BPTT. This process is nothing but the back propagation through time. Okay. Once the network is trained, definitely it will going to predict the next sequence given the previous sequence data as an input. So once it produces the data, it will give it to the next sequence as an input. Then it will start processing. Okay. So again, once this has been done, this will become the processing data of this particular will become an input for the next one. So after processing, whatever the output that you get, that will feed it as an input for the next one. This is how the process follows. This is nothing but a state-of-the-art algorithm, especially for the sequential data. For example, what are the applications where we are going to use speech recognition, machine translation, as well as robot control? So let us understand a little bit in detail what is the application with respect to the speech recognition. As you are aware, Alexa and Siri are nothing but a speech recognition modules, right? Here, input is nothing but the audio clip and the output would be a transcript. Here, what we do is, whatever we are going to speak, it will broken into a chunks and it will pass through the recurrent neural network. It will process in that way. We cannot, this entire sentence cannot be fed directly to it for processing. It will divide it into a chunks and then it will start processing. Machine translations. When you're translating speech or a text from one language to the another, we cannot do it at one shot. We do step by step. We divide the whole thing into a chunks and then we'll start processing through the chunks. Okay. Robot control. You know, robots are being implemented using this recurrent neural network to do the surgeries, right? And it will help you to control the equipment where humans have a higher error rate compared to this. So that's the reason we go ahead with the robots. So, and captioning of the images. When you want to process creation of the text, for example, you are seeing this particular image, right? If somebody wants to write the caption for this, you have to analyze this particular image. Then only you can able to update the text. So that particular applications can be done with the help of RNN. And for example, forecasting. Stock market is a very good example in this case. So wherein we prefer to go with the RNN. So even though RNN is there, we have found a lot of issues with respect to RNN. There are a lot of limitations to use this recurrent neural network. The context or memory changes too fast. That's the reason we have gone with the LSTM, control this context change rate. What do you mean by LSTM is long short-term memory. This control the context change rate. See, this is a little bit slow and it requires a complex training procedures as well. And it is prone to problems. Error rate was more. That's the main reason we usually don't prefer to go with RNN. Even though RNN architecture is there, the same basic architecture we have used and developed the different architectures. We call it as LSTM, right? So we prefer to go with LSTM for many problems to solve instead of going with the actual or what we call it as a normal RNN. RNN has vanishing gradient problems. It doesn't preserve the context well when the data sequence is large. LSTM is an alternate architecture to solve this issue. I'll just give an example for this. It shows that gradient problem is there. It doesn't preserve the context well. For example, I gave an example of the Alexa, right? You're going to ask a question for Alexa. Alexa, how is the weather today? It will going to come up with an answer. The temperature is too hot or something like that, it will answer. And then the very next question you'll ask, whether do I need to carry umbrella? So what happens, Alexa takes the very next questions in a different context. It doesn't relate the previous context. On what context you have asked? If it is hot, you have asked whether do you need to carry umbrella. But Alexa doesn't relate the previous question with the current questions. It will answer it in a different variant way. So which means that the main functioning of the Alexa is not happening in a proper way, right? The main reason why you have asked to carry an umbrella is whether it will going to rain or whether it will be very hot for you to go out, right? So it has to answer in a proper way. It has to relate the context. When there is a large data sequence, one by one, if you start asking the questions, it doesn't relate the questions. That's the main reason why this RNN is a faulty one. Hence, we prefer to go with the LSTM. This is again a new architecture. It's an alternate architecture to solve this kind of the problems. So how it will eliminate the context change can be controlled using this architecture. Whenever there is a change in the context, it will going to replace this architecture. It can add or remove the information to the cell at a desired rate. It solves definitely the issues which is faced with the RNN. Okay, so that's the main reason when you talk about RNN, we'll go with LSTM, long short-term memory architecture. Now, this is about the RNN. Let us not go in depth of this RNN. Just understand RNN is mainly for sequential data. CNN is for image. And for the other normal data, we prefer to go with the deep learning. And how this going to impact the business, right? So deep learning in various domains, we use it in finance, retail, healthcare, as well as in case of energy. Definitely, many organizations are investing huge amount of money on the deep learning because we see rapid adoption of this particular concept across the domains in many of the domains. So let us see some of the examples. Whereas in case of finance, how do we use this deep learning concepts? Fraud detection, loan and insurance, portfolio management, and the algorithm trading, right? So we are going to use the RNN concepts, RNN, the advanced version of the RNN architecture, right? So this is the main areas why we prefer to go with this. When it comes to the energy consumption, not to save that and to have a better production. In case of healthcare, to detect the tumors and detecting disease, oncology. I'm talking about deep learning concept as a whole, not with respect to CNN or RNN. Retail, learning behavior, purchase patterns, and detection of the frauds in online retails. So you have seen the advantages of the deep neural network, or what we call the deep learning, to adopt in various industries as the domains. Now, how to operationalize these great ideas, how to get into how the implementation happens, right? We cannot sit and design from the starting. We already have a frameworks and the popular frameworks which are available currently. We can definitely borrow that and start consuming that. Frameworks are nothing but simplify the development of the software products. It's nothing but a collection of libraries and classes with a common goal on which we can build the software. So we cannot start building from the scratch. Frameworks are available. Take it up, buy those frameworks, and start utilizing in a way that it has been required. Okay. Some of the popular frameworks in the market are these: TensorFlow, Thin, DLJ4, Caffe, and PyTorch, and all. These are some of them are open source, and some of them, for example, Keras has been developed by the Google, and PyTorch is a Python version of the framework. and Cafe is a C++ based, so Java and Scala based, right? And there are certain popular products also which are available. H2O, IBM Watson, Amazon Web Services, Baidu, Apache Spark. These are all some of the popular products are readily available. Either you can go ahead with directly with the products, or you can take the framework and modify as per your requirement. Okay, this is about the introduction to deep learning. Thank you so much for all attending, and let me conclude the session. Given the data and the problem statements, always we prefer to go with the ML because it's the best version to use the ML compared to the deep learning. Because I told deep learning requires a lot of computational power, resources, huge amount of data and all. Definitely ML is not at all a failure. It is underperforms based on certain type of the task. And a lot of expertise is required when you want to handle these type of architecture. You might have seen the basic understanding of this architecture. It is not so easy to understand. It is a little bit complex. So expertise is required to understand the architecture. And definitely it is a quite interesting domain. If you're interested to build your career, definitely it will be a very good choice. Okay. So programming, or what we call it as coding, is not a must for this, but definitely when you want to build architecture and the other stuffs, yes, you need to learn the programming concepts as well. Okay. So with this, we have come to an end of the session. I'll take up a few questions because I have call it in under 2 to 3 minutes. Quickly, I'll take a few questions, and the rest, I think, Prithvi, you'll be able to take up those, right? Difference between products and framework. Frameworks are nothing but just the skeleton, right? For example, for image analytics, there will be already a skeleton which is available. You can take it up and use up to whether you want to use for face recognition or whether you want to use for X-ray. You need to make changes according to your requirement, whereas the products are readily available. For analyzing the X-rays, the product is available. You go ahead and buy. There are various vendors which they are going to sell, right? Do we need to learn any of the frameworks? No, you need not learn any of the frameworks, in the sense when you are in the implementation part, yes, you need to learn. But currently this is an introductory session. For people who are interested to develop or learning in depth of deep learning, definitely you need to learn. Not saying no for it, but you are just learning the basics of it. In order to use all these frameworks, yes, definitely expertization is required. You cannot do it at the very basic level. You should have a very good exposure and experience to handle these. Okay. Now you can just be aware of it. Just have the basic knowledge will suffice for now. Will you cover any of the framework? No. These are the introductory sessions. We are not going to cover any of the autoencoders or nothing, but it's a type of deep learning again, which we don't prefer to use much. That is mainly used for error rectification. Okay. RNN is similar to the supervised regression technique. Supervised regression technique are nothing but algorithms. You can use either for CNN or RNN depending upon the issues or the task that you have. Which is tokenization used in the speech recognition. Tokenization is nothing but what? The entire sentence is divided into tokens. Each word is a token. Okay. Yes, when the image size is small, then definitely you need to have a better clarity. If you don't have a clarity of the image, definitely you cannot expect that great output. Accuracy won't be much. It depends upon the pixels. Pooling is nothing but padding is what? Adding an extra pixels. Pooling is not what? You're going to reduce the output. How do we reduce? Either you can take the max or you can go with the average. So the dimension of the output will be reduced with the pooling concepts. Convolution is nothing but rolling. Please go through all these concepts, are very well explained in the course. Post that, if you still have any questions, definitely you can always come back to us in the very next session, right? If you pursue a career in Gen AI, should we learn any programming languages or ML in depth to understand the concepts of AI? Generative AI is a bit different. See, how do I explain? ML is a concept. Generative AI is the application of using. Why are we doing pooling and padding? See, we know that, once the output is reduced, when we do a convolution, the input size is bigger, the output was smaller. So there are chances that we may lose the information at the edges of the image. So that's the reason we go with the pooling. Padding. Why we go for pooling? Because padding, it's a huge amount of data, right, to process it. So we want to reduce it. So that's the reason we go with the pooling, either max with or with the average pooling. Autoencoder is nothing but a type of measure, deep learning actually. You would like to know in depth of this? Not much is mentioned here. PPT cannot be shared actually. This is just for our internal purpose, but I'm pretty sure whatever has been put it in the PPT, everything, all the concepts have been updated in the course as well. Okay. Prithvi or Aishwarya, are you there? Hands-on application, Shruti, because we have different kind of participants here, right? So directly we cannot go on with the hands-on. That's the main reason we are keeping it very brief or the minimal information over the classes. So in case if you are really interested to learn and go in depth, please refer to the courses. There are many courses with respect to this. Definitely you can leverage your learning through this. Computer vision, yes, also used in the image analytics. True.
Girija ma'am, I'm back here. Sorry, I just logged out for a few minutes.
Okay, no worries. Prithvi, we are done with the session. I have to edit into the platform call now. So
Sure.
you can note down all the questions, and if you could answer all these questions, that would be great. For few of them, yes, I have answered. The rest
Okay.
I need to take, since the time got over. I need to drop off for another call now. Okay.
Sure.
Thank
Yeah.
you so much for all the participants. It was a very great interactive as well. So thank you so much for your time. Request you to complete the self-assessment at the end of the course. I hope it is informative as well as useful. Yes, it is quite interesting. As I told, it is very interesting to build your career. Really, there are many courses in the Springboard platform. Request you to please go through based on your interest levels. Either you are interested with a beginner or advanced, or some of them was asking for the hands-on. Please refer to the courses. There are courses available for that. Okay. Thank you so much. You can share your feedback to Prithvi. Thanks for it. Yeah.
Participants, please do not leave the session. I'll just give you the meeting link here.
Yes, please.
Sorry,
I'll be dropping off, Prithvi.
course link.
Thank you.
Yeah, thanks so much, ma'am, for facilitating the session.
Thanks. Thanks. Bye-bye. Have a nice day.
Yeah, thank you, ma'am. We have a question from Swati. NLP session was a little brief. Could we have one more session if possible? Definitely, ma'am. I request you to please go through the course material. The link, I'll be posting it once again. In detail with the examples is beautifully explained and illustrated in the course material. In spite of that, if you have any doubts, we can have one more session clearing all the doubts for all the aspects of AI. I hope that that helps. And as mentioned, I have noted down the questions here, which was unanswered, or we'll take it up once again. I'll just share my screen and show you how you can look up for the course for uh, today's session. Just a minute. Avneet, are you there? I think I've given you the co-host access. You can unmute, please. Yeah. So the session today was on introduction to deep learning. So you can look out for introduction to deep learning on Infosys Springboard. I'll just share my screen. Please let me know if it's visible. Yeah, this screen visible to all of you? All you need to do is just type in introduction to deep learning. This is the course that you need to look up for. It is a 4 hours 53 minutes course, which talks to you about why is deep learning important, what is the potential of deep learning, business potential of deep learning, and it also talks to you about the convolution neural network and the recurrent neural networks, and what kind of applications, where can you use CNN and where can you use RNN. It also talks about autoencoders, as well as the different frameworks and the programming language that you can use for deep learning concepts. And finally, at the end of the course, you have a self-assessment also. I presume it is around 15 questions, which needs to be answered within 30 minutes. So please take up this, go through the course completely. It's a little different concept and slightly complicated to understand, but it is very beautifully explained here, whether it is CNN or ANN and its applications as well, where exactly you can use these concepts. I'll just post this uh, course link as well. Yeah, somebody had asked a question as to, is it is deep learning supervised method? Yes, it is a subset of machine learning. As told, this deep learning uses neural network technique. So based on the problem or the complexity of the problem, we can choose whether it is a supervised learning or an unsupervised learning algorithms can be used there. If we are in the midway in between the course, how can we finish the same post the expiry of these courses on Springboard? As of now, there is no expiry of these courses on Springboard. As I told you, the courses that you take from Infosys Wingspan has no expiry as such. Either it'll be there, or an upgraded version of the same course material may come up on the platform. So you don't have to worry that the course will get deleted from the platform. As long as you take it from Infosys Wingspan, the courses will be there. If for now it might be an introductory course, we might come up with a more detailed version of the same topic eventually. So as I told you, it is not necessary that you need to study or learn only on the topic that we have mentioned. You can look up for deep learning courses from the other sources also through the platform. Yes, Coursera courses have certain expiry date. Since it is provided by a third-party vendors, you need to finish the course within that particular time period. In case you are in the midpoint and you will not be able to finish the course material, uh, um, unfortunately you cannot finish it at the later point in time. That the vendors may delete the course or upgrade it into a newer version of the course. So please ensure that within the expiry date the course is completed and you obtain the certificate also. I hope that answers your question, Hemalata ma'am. Okay. Not able to get the certification for introduction to AI after completion. Are you sure, Bhanumati ma'am, you have completed the course completely and your learning progress is 100% here? As I told you, when you start, click on the start option, be it any course from Infosys Wingspan, there is an option here to get into the table of contents. And if you go to the table of contents here, you just like in your WhatsApp, once you send the message and when the other person has read the message, you get a double tick, right? So same double tick appears here as well after finishing all the sub contents or the subtopics from the course module. So ensure that this is done and then check for the certification. If you have passed the self-assessment with 60% and above, you will definitely be getting the certificate. In case you don't get it, I repeat again, please post in your the screenshot or the error screenshot to springboard-support@infosys.com. And somebody was asking about NLP as well. We'll take up that session again if required. It's called Introduction to Natural Language Processing. From Hershakti team, if they are there, I request you to please pitch in here. I request you to please share the links once again with the participants.
Hi, Prithvi. Yes, all the links are there in your groups. If you can just scroll a little up, all the links have been shared. I will share it again, once again. And those who have not been able, those who are facing the problem can ping me directly and we will be able to share the links again with you. Because most of the candidates have already finished all the courses, all the trainings which were there pending for these last 2 weeks. All of it has already been covered by most of them. So those who have faced the problem can please message me. I will be sharing the link again with you all.
Yeah, there is one question from one of the participants, Deepa. These Coursera, Skillsoft, IHT are content providers. They are separately, they have their own digital content providing platforms. But we as Infosys Springboard, since this is a CSR initiative and it is accessible by all learners for free, we have purchased those courses from the other content providers, be it Coursera or Skillsoft, and we have added the courses that is required for today's to know about today's technology and era. So we have taken those courses, purchased those courses from them, and added it to this platform, so Infosys Springboard platform. So how Infosys Springboard platform is different from other platforms? One thing is this is free of cost and accessible for all the learners. And you don't have to pay to learn through this platform, whether it is a content or a knowledge material or even certifications, everything is free of cost. And at the end of it, whether it is from Coursera or whether it is from Skillsoft or whether it is from Infosys Wingspan itself, we award you the certificate saying that you have completed the course on such and such a topic, and you will have Infosys Springboard on your certification as well. And suppose if you are a learner from Skillsoft or Coursera, even though you have learned it from them, you will be a learner of Coursera or Skillsoft, but ultimately Infosys Springboard will award you the certificate if at all you finish the course assessment or the certification. I hope this answers your question. Sorry to say this, but I myself have taken the assessments and the certification. All of the links are perfectly fine. I request you to please do not skip any subtopic. Go through the subtopics completely, attend the quizzes, the exercises, and the assignments that are given under each and every topic, and then switch or to jump to the self-assessment part. Infosys Springboard credentials is valid lifelong as long as you can remember and reset your credentials. You don't have to worry on the expiry, ma'am. You can use this platform for as long as the platform is there, you can use it for learning. Many may okay, may I know within what date we have to upload the course certificate? Avneet and team, are the participants sending the certifications for you people?
Yes, Prithvi, we have received, so we had shared one Google form with all the candidates, and we
Okay.
have received the certifications from the participants who have covered all the trainings. They have shared it with us.
Yes.
So we
So
have
to
that data.
answer one of the questions from the participants, it is better you complete the course within that week period. Since today we have done the session on deep learning, you have 1 week time. You have complete 6 days to go through the course. The course is just for 4 hours 53 minutes, but you have complete 6 days with you to know more about deep learning and to come up with questions and your doubts. We'll definitely take a day to answer all these questions before we move on to the next topic, which is on agile methodology. Probably we'll have to need one more day just for doubt clearing and to understand the concepts better. We'll do that. As I told you, I have taken down the questions. We are not that experts to give you the correct answers, so we'll definitely reach out to our experts here at Infosys Springboard and we'll answer your questions. Preferably within this 1 week, please complete the course material and submit your certificate to Hershakti team. Okay. Why is the Coursera course valid only till June? As I told you, ma'am, this is not in our hands. It's a third-party vendor's course. So we do not have a handhold on it. We have got the opportunity and to use those course content also. So within the expiry date, kindly avail it and finish your course material. Okay, there are few more questions. I'll once again post the course link of Introduction to Deep Learning. Trust me, the course is very well illustrated. You don't need any recordings or you can make your notes post the learning of this particular course. It's called Introduction to Deep Learning. And there are many other courses with the same name from different sources. Please go through that as well. Natural language process course, I found it difficult. Kushbu Jain, ma'am, I request you, I am also not from the technical background, but still after going through the course material on Infosys Springboard, because of the various illustrations that is mentioned, I found it easier to understand. I request you to please go through the material once again. As I told you, NLP, it talks about the challenges as well, and it also talks about the NLP pipeline with very good number of examples here on the course material. Avneet and team, we can have one more session based on the completion of all the concepts of AI.
Okay,
I'm
Prithvi,
sure,
you
yeah.
help us with the date, and we should be able to plan the session as suits your team as well, and the participants will be informed according to your confirmation.
Sure. There is one question from Baswaraju Nandini. What is MNIST dataset? I am not aware of this, ma'am, but I'll get back to you with this.
So one doubt from my side, Prithvi.
Uh-huh.
So since we have the next session aligned on 16th of May, so would request you to keep if you can keep a session, doubt clearing session before that. That will be great, so that till now whatever we have covered, we shall be able to summarize in that session.
According to my opinion, 16th of May would be the last two concepts of AI, one which is on
Yes,
robotic
yes,
process automation and computer vision.
correct.
I prefer post this
After
session
that,
on 16th, we can have one session between 17th and 22nd.
okay, 17th
Doubt
and
clearing
22nd.
sessions.
Sure,
Yes,
sure,
I think
Prithvi.
that will be preferable so that we can answer all the questions with respect to AI aspects.
Right, right. That makes
Because on
sense. And
23rd, we'll be getting into a different concept called agile methodology.
right.
So before that, we can have one class for
Yes,
doubt
sure,
clearing as
sure,
well.
Prithvi. We can
I
plan
hope this
this.
works with the
Yes,
participants as
yes,
well.
yes. We shall be, pre-informing them as and when I'm getting the dates from.
Definitely.
Sure.
Definitely. Is
Thank you.
computer vision also used in image analysis? Yes, it is. It is used in image analysis. Uh, yeah, I think pretty much I've answered all the questions, and my colleague Girija has also answered it. We'll be copying the chat, and if there are any more technical questions, we'll come back on it. How do we get confirmation that our certifications are recorded by the team? I think a Google form is sent wherein you will have to upload your certifications, right? Gitanjali ma'am, I hope that answers your question. Harshita, can we get study material? As I told, it is available on Infosys Springboard. Just type in introduction to Infosys, introduction to AI, artificial intelligence, natural language processing, and deep learning. Apart from Infosys Wingspan, there are many other content available from other sources also. Please look out for that, and you can have the learnings. All the PPTs that has been used for explanation is also taken from the same, so you can refer to the course material. You have to log into Infosys Springboard, Mona, to access the course links. Without logging into Infosys Springboard, you'll not be able to access the course links at all. So that's the reason we say have your registered ID in place so that you can use it. Is generative AI beneficial for UX designer? I think it is, yes. User interface designer technology is also a web technology, right? I'm sure it is useful. After self-assessment, the page does not redirect. Redirect to what, Kushbu Jain? Once you finish the assessment, uh, you'll have to come back to the same course page, and here you get an option called as generate certificate. If at all you have cleared with 60% and above, you'll have the option to generate the certificate. It will take some time to generate the certificate. Then you have an option to view your certificate as well as download the certificate. I think this is pretty much it. I think I've answered all the questions. Yeah, Avneet and team, I request you to please share the list of certificates or the courses that needs to be completed by the participants.
Uh,
Once
uh,
more,
okay, I shall be doing so. But again, I'm repeating the things. Ladies, every information is available in your WhatsApp group, along with the study links, the joining links, a list of the certificates which you have to share with us, the schedule which you have to follow for the week. Everything has been shared. Request you all to please just go through once in your respective groups, so that you are not missing on to any information part of these. Okay,
Yes,
so
and
please
last
be
question.
attentive there.
Yes. And last question by Swati. How many times can we take up the assessment? You can take it up a number of times. Even though you have scored 60 or 65%, you want to retake the assessment too, you are welcome to do so to get more score. Since there is no cap or the limitations, the number of attempts, you will not know which question you have gone wrong. So to know that, you can reattempt it again and again. The latest attempt and the latest certification will be updated on your profiles. Yeah, this is pretty much it. So I hope to see participants completing introduction to deep learning also. The next session will be on the 16th of this month, which is on computer vision and robotic process automation, and yet another interesting topics, which is an aspect of AI as well, wherein you will see how deep learning concepts like CNN and ANN is used for image analysis and speech analysis in the next topic, which is RPA and computer vision on 16th. So please join in for the next session. I request once again to all the participants, join in before 11 o'clock. The link will be shared, the new link will be shared for the 16th to Hershakti team, which will be in turn posted to you all. So thanks for joining in. Happy learning through Infosys Springboard. Thanks, Avneet and team. Yeah.
Okay, Prithvi. So I think let's call it a day and wrap up. Okay, ladies. Any other questions? If you have, I'll request you to please get in touch with the Hershakti team. We will be able to solve your queries. So thank you so much, Prithvi.
Yeah.
Yeah. So let's
Yeah.
call it a day and all the
Perfect.
best. Happy learning.
Yeah. Thanks, everyone.